to talk on this topic, we have with us Ritesh Chandra. Thanks once again, Ritesh. Thanks for joining.
Yeah, hi everyone.
Right. So just to give a brief background, to introduce Ritesh is a seasoned banker with more than 1.5 decades of experience, but primarily in credit and risk management, and he was working as president of a leading private sector bank. Prior to that, he was in IT consulting and had worked in variety of roles in India, China, and Canada. He is very passionate about teaching. I can vouch for the fact. He has been associated with IIQF as well for almost a decade now. He conducts various workshops and training programs for more than 6-7 years. I mean, as I said, with us more than that. So his areas of interest are primarily credit risk, quantitative finance, statistical learning, and of course, to further that, he has a lot of interest now in machine learning, blockchain, and other advanced technologies and areas in finance. Ritesh has done his PGDM from IIM Calcutta, and he is a BTech from IIT Kanpur. He is also a member of Board of Studies in the area of finance management at IMT CDL Ghaziabad. He is a CFA chartered as well. So with that, I'll hand over the session to Ritesh. But before that, very brief lowdown on how we would go about this session, right? So as you all know, the session is about 1.5 hours. So in the first 1 hour, Ritesh will be taking us through on this topic, and then post that we would be having a Q&A. And of course, we want the session to be very interactive. However, since the participation is quite big, so unfortunately we would not be able to unmute you all, right? Because that would be a little difficult to manage. But nonetheless, please feel free to type in about yourself. Type in any questions, queries, or any particular topic within realm of today's discussion areas that you want us to take us on. Any questions you have, any queries that you have, please feel free to type in. We would be happy to take it up, right? Once the session is over during the Q&A session. So with that, I'll hand over the session to Ritesh. Ritesh, I'm making you the presenter. Please feel free to start the session whenever you are ready.
Can you see my screen, Ritesh?
Yes, we can see your screen, but we can't see you. In case if it is possible, please switch on your webcam as well.
My webcam is switched on.
Okay. Cool. Yes.
Some problem with my camera or something, probably. I don't know.
No. Yes, I can see you.
Okay. Yeah. I can see you.
So, a very warm welcome to all of you, and thank you to IIQF for inviting me to do this presentation. So, as you know, the topic is fraud detection using ML, in which I would try to give you a brief about the problem of fraud detection, the landscape of fraud detection, why it is important, and what are the various techniques that people have been using for fraud detection, and especially when it comes to using advanced data analytics or machine learning techniques, how they have been using machine learning algorithms. Okay, so before we begin, let me just take you to the understanding of what is the scale of the problem that we are talking about here. And there is an excellent report which periodically comes from the US Federal Trade Commission. And this is the link to that I would like to show you. So you can see that in 2023, almost 5.5 million reports to the Federal Trade Commission in US about fraudulent activities, and out of which 2.6 million were fraud reports, and the total fraud related losses was close to $10.5 billion. This is the first time that the number has crossed this $10.5 billion, and you can see the top 3 categories: identity theft, imposter scams, and credit bureau and information furnishes. In fact, this is an excellent website for anyone to go there and check about these things. It's a group of tableau-based reports that they publish, and it's so many things that you can get to know about here. So for example, if you go to this report, it will tell you the breakdown of fraudulent activities that people have reported in the US quarter-wise. So what is the quantum of the fraud, which area, what are the trends, what are the key facts? All of them are there. Okay. Now, so the moral of the story is this is a problem which is becoming bigger and bigger, especially as our lives, our economic activities, our societies get digitalized. The problem of cybercrime or online frauds or frauds where computer technology is being used, that is becoming very, very prevalent, and there is a increasing interest by government authorities as well as public at large to understand how we can stop these things. You would have seen in Indian context, for example, Airtel recently has been advertising a lot about how they are going to use AI to stop or at least try to mitigate the menace of these online fraudulent calls. I'm sure many of you would have got these calls from Telecom Regulatory Authority of India, which says that your number has been marked for illegal activity, and if you don't call them up in a couple of hours, they will freeze your number or they will disconnect your number. Even the Prime Minister has highlighted the menace of these digital arrests which are happening in India these days, and people are being swindled of their money. People are ending up paying large amounts of money to such fraudsters. So the menace is real. The menace is real, and there is a growing interest in how to solve this menace using the power of technology. Okay. Having said that, let's first try to define what fraud is. And I was looking at the Oxford Dictionary, and it says that fraud is any wrongful or criminal deception which is intended, sorry, just a sec, which is intended to result in some kind of a financial or a personal gain for the fraudster. Now, this definition is quite good in terms of defining what fraud is. Okay, but if you have to develop a fraud detection system, I don't think this definition is very practical. Okay, so normally when we think of fraud in terms of designing a system to mitigate fraud, we have to understand what are the characteristics of a fraudulent transaction, because that will help you a lot in understanding how to develop a fraud detection system. And number two, in understanding what are the challenges in developing such a system. The first characteristic is fraud is uncommon. Just like credit default, majority of the people are good people. So fraud, first of all, is a uncommon event. That is why it is difficult to detect fraud, because in the entire universe of sample events that you are going to look at, majority of them are clean transactions. So it's difficult to detect. And similarly, another challenge is even if you develop a system to detect fraud and you try to train that system on historical database, you do something called backtesting. Now, because fraud by itself is an uncommon event, it's quite difficult to arrive at a good backtesting result, because even in the training sample, the actual instances of fraud would be very low in the entire gamut of transactions that you are covering. It is a well considered thing. Fraud is not something which is happening by chance or by coincidence. No, it is a well considered and well concealed activity by the fraudster. The fraudster is doing everything possible to conceal the fraudulent activity. It is not impulsive, it is not unplanned, because if it were, then detecting it would have been far easier. Very important aspect is fraud is adaptive. or it is evolving with time. That means you create a system to detect and prevent frauds, and the fraudster will refine their methods so that they remain undetected. So fighting fraud is a ongoing activity. You create a system, fraudster will refine his technique, he will come up with new technique, you will have to refine your system. Then in many cases, fraud is a very carefully organized crime, meaning there are a group of fraudsters who are not operating independently. They are not operating independently, they are operating as a group, they have allies, and they have a certain process and modus operandi. Okay, especially when it comes to things like money laundering. Okay, complex structures are set up so that the fraud can be organized in a manner that people cannot realize that they are being defrauded. What it means is that don't think of fraud as some isolated single incident. You can think of fraud in a context. That means there is a social network of these fraudsters. And that is why, besides the historical techniques, these days you have something more called social network analysis or social network analytics. This is a branch of analytics which analyzes the social network of suspicious transactions or the entities which are engaged in those transactions to figure out the larger picture. And finally, fraud can take many different forms. Fraud is not something which is of one type. Fraud can be of multiple types. Okay, so let me just highlight some of the more common types of fraud. Credit card fraud. So we all now know about credit card fraud. Either someone can use your credit card in an unauthorized fashion. They could counterfeit your credit card. They could use a lost or a stolen card, or they could fraudulently acquire your credit card through email from the courier. Okay. Then you have application frauds. That means applicants obtain new credit cards by providing false information, false personal information to the credit card company. And once they get the credit card, they try to exhaust it as soon as possible. Then you have these behavioral frauds where details of legitimate cards are obtained fraudulently and then sales are made through those cards. So all these come under credit card fraud. Then you have insurance fraud. That could happen from the side of the buyer of the insurance or side of the seller of the insurance. Okay, so for example, from the seller side, you could be sold policies from non-existent companies. You can, you might fail to submit premiums and you can churn policies to create more commissions. Then you can have frauds from the buyer side where people submit fraudulent claims worth more than the value. In so many cases, you will find there are fires in godowns or some mishap will happen. And with some companies, you will see that it keeps happening in a recurring fashion. Okay, so that is insurance fraud. Then another kind of fraud is counterfeit. This is like an imitation where something which is non-genuine is made to pass off as the genuine article. So counterfeit typically is about valuable objects, credit cards, ID cards, money. Counterfeit money is there. Then you have healthcare fraud. So in healthcare fraud, you file these dishonest healthcare claims in order to make profit. That is healthcare fraud. You have telecommunication fraud, theft of telecommunication services or the use of telecommunication services to commit other types of fraud. So for example, these days, something called SIM cloning, where criminals are able to clone your SIM card. This is what you call some kind of a superimposition fraud, in which fraudulent usage is superimposed on the legitimate usage of your SIM card. Then you have money laundering, in which the proceeds of criminal activity are made to appear legal, and it allows the criminals to transform illegally obtained wealth from corruption, from narcotics, from trafficking into legitimate funds. This is a huge problem which governments and central banks and regulatory authorities are trying to deal with across the globe. Okay, and then of course, identity theft. It is about obtaining the personal or the financial information of another person with the purpose of assuming that person's name or identity in order to make transactions or purchases. Okay, so all these are different kinds. There are many other types of frauds. Even tax evasion is a fraud, corruption is a fraud, plagiarism is a fraud, but these are some of the common types of frauds that you may come across. Okay. Now, once we have an understanding of this, let's talk about how fraud detection techniques have evolved. Now, the classical approach to detecting fraud is what we call the expert-based approach. Why is it called so? Because it depends, or it is built upon the experience, the intuition, and the domain knowledge of the expert, who in this case is the fraud analyst. Now, in such an expert-based approach, typically what will happen is whenever you have a suspicious case being reported, there will be a manual investigation. And this suspicious case would have been flagged by someone. So for example, suppose a customer complains to a bank that they are being charged for transactions that they did not do at all. Now, this disputed transaction may be some kind of a new fraud mechanism which the fraudsters have developed. So it needs a detailed investigation to understand why this happened and whether there was any fraud element involved. Okay. In this approach, in the expert-based approach, what happens is the expert or the fraud analyst, he tries to get into the details of a case. And if he or she comes to the conclusion that a fraud has been committed, then they would update the details of that fraud, the methodology by which it was conducted, what were the ramifications, what were the signals, how it could have been avoided. All these things essentially are used to create a rule-based engine. Okay. So in the expert-based thing, you create what you call a rule-based engine. A rule-based engine essentially the set of if-then rules. So you will add the rules that describe whatever fraud mechanisms you have detected till now, and these rules are essentially applied to future cases or transactions, and they will trigger a signal or an alert when fraud may be committed by use of this particular mechanism. This is a very simple approach to fraud detection and prevention, but quite effective. Okay, this is quite effective. So for example, I've shown you an instance of a rule-based engine which can be used to detect a fraud in an insurance claim setting. So for example, the rule-based engine would say that if amount of claim is above some threshold, or there is a severe accident but no police report has been filed, there's a severe injury but no doctor report is there, claimant has multiple versions of accident, or multiple receipts have been submitted, in all such cases, a suspicion flag would be raised. You will flag the claim as suspicious and you will alert the fraud investigation officer. Okay, sounds very simple. However, this approach of an expert-based system and a rule-based engine have a lot of disadvantages. The first disadvantage is this kind of a system is quite expensive to build. Why? Because it requires inputs by the fraud expert, and therefore it is also difficult to manage and update and maintain. So rules have to be kept updated from time to time, and what happens is only for the real fraudulent cases, because every signaled case, so what you have to do is you have to also understand that there could be so many rules, but you don't want to go on a wild goose chase. Okay, so rules have to be kept updated, and you would enter the rules only for those cases which turned out to be actually a fraudulent case in the past. Why? Because every alert needs to be followed up by a manual person, by a manual fraud analyst, and you don't want to raise false alarms. Okay. Uh, the other challenge with this system is over a period of time, fraudsters are bound to learn why their fraudulent activities are getting exposed, and they will invent a workaround. They will invent a workaround by trial and error, because that's how they are also adapting. Now, in this rule-based engine, the rules, they are based on past experience. So if there is a new fraudulent scheme that has come in the market, the rule-based engine will not be able to raise an alert or a signal. So remember, fraud is not a static phenomenon. It is a dynamic phenomenon. This rule-based engine is only based on what you have observed in the past. So because fraud is a dynamic phenomenon, so you need to keep tracing fraud continuously, which means any fraud detection and prevention system that you design, that needs to be continuously monitored, continuously updated, so that it continues to be effective. So that is another challenge. The third challenge, I would say, especially in today's online world, is where we are generating gigabytes of data every single, say, minute or an hour. This one involves a lot of manual intervention. This is labor intensive. This is labor intensive, and therefore you might want a system which requires less human intervention, in the sense that the system is automated. Okay. So given these limitations of the expert-based or the rule-based approach, people have started moving to what we call data-driven fraud detection. So I'm not saying that the expert-based fraud detection approach has gone out of fashion. No, it's still there, pretty much there. But now we have also started using what we call data-driven, or you can call it statistics-based fraud detection engines or systems, for three primary reasons. Precision in the sense that statistics-based fraud detection methodologies, they offer you an increased detection power compared to the classical approach. Okay, so because using a statistical tools, you are able to process massive amounts of data, so a fraud pattern can be uncovered, which was, say, not very apparent to the human being or the fraud analyst. Okay, plus with most of the organizations, they only have a limited capacity to have cases manually checked by the fraud analyst to confirm whether or not it actually involves a fraud. Okay, so when you are designing a fraud detection system, one of the goals is also to make the most optimal use of the human resources that you have available. That means you want to maximize the fraction of fraudulent cases amongst the cases which the human being is asked to investigate. Okay, so if you have a database system, a statistics based system which has a high precision in terms of signaling a red flag, then it also translates in a better and a more optimal usage of your human resources. That is one angle. Operational efficiency. So in a lot of settings these days, a very high number of cases need to be analyzed in a short period of time. And that is only possible if you use an automated process which is based on statistics or machine learning. Also, in several cases or in business processes, there would be operational requirements, like there could be a time constraint on the processing of a case. For example, if you are evaluating a transaction which is happening through a credit card, you have to make an almost immediate decision whether you want to approve the transaction or block the transaction if you think that a fraud is being committed. Okay, or suppose goods come at a port and the customs people are inspecting the goods. The decision has to be made within a confined time window whether you want to let the container pass and shipped, or whether you want to further inspect it, because that is going to cause more delay. So again, because of these operational requirements, data-driven techniques might have an edge over the classical human-based approach. And finally, costing is there. Okay, so if you have a very manual or a human heavy system, manual resource heavy system, then it costs more. On the other hand, an automated system might be better in terms of overall costing. So these are three primary reasons why these data-driven fraud detection techniques have become popular. And one more reason which comes to my mind is there is a growing amount of interest amongst the general public, the media, the government, and the corporates. Okay, these days fraud is being seen not as something which we can, just let it pass. It is being seen as some kind of an organized crime which has a social and financial ramification. And there is a growing interest in terms of uh, how to tackle this menace by developing better tools, and that also has led to what I would say an interest in statistics driven tools. Okay, now let me just talk about three primary techniques that you use in a statistics driven system, because machine learning also is a statistics driven system by and large. The most common one is what you call unsupervised learning or descriptive analytics. What you are doing in descriptive analytics is you are trying to figure out outliers. That means the objective is to figure out any pattern which is deviating from normal behavior. Or what you call anomaly detection. So what these techniques do in unsupervised learning, they learn from the historical observations. And why are they called unsupervised? Because those historical observations have not been labeled as a fraudulent or a non-fraudulent case. No, they are essentially, the unsupervised technique is looking at all the transactions or all the events or all that has happened in totality, and it is trying to figure out those data points which do not seem to fit the normal behavior. That's all. Okay, then okay, this technique of outlier detection, mind you, is very, very valuable, especially if you have to detect fraud which is different from historical fraud. So if the fraudsters have come up with a novel technique, if they are using patterns or mechanisms which were unknown earlier, those new patterns cannot be discovered by expert system because they are yet to even get to know about them. And therefore, descriptive analytics or unsupervised learning, I would say, is the first complementary tool. So the organization will have an expert-based system, and to complement that expert-based system, they will add an unsupervised learning layer on the top of that. However, like any technique, it has some limitations. So descriptive techniques can be prone to what we call deception, meaning if the fraudster is trying to camouflage his activity, it is possible that it does not show any deviation from the usual pattern, and therefore the unsupervised learning technique is not able to detect it. So how do you improve upon that? You bring another technique which you call supervised learning or predictive analytics. Here the idea is that you learn from historical information to understand patterns so that you can differentiate between fraudulent and normal behavior or non-fraudulent behavior. The objective of the supervised learning or the predictive analytics technique is to find the silent alarms. It's about finding those parts of the track which the fraudster is not able to cover up. And these techniques can be applied to predict and detect fraud and also to estimate the amount of fraud. Again, this technique has certain benefits, predictive analytics, it has certain limitations. Limitations are, I would say the most important limitation is that it will require historical data from which it can learn. That means you need a labeled data set. That's why it's called supervised learning. You need the transaction details along with a labeling whether that transaction was ultimately a normal transaction or a fraudulent transaction. Because of this, if the fraudsters are making use of new mechanisms or new methods which have not been seen in the past and which have not been labeled in the past as fraudulent, then this system may not be able to detect that. So that is why I told you it's not that you use one technique, you have to use a combination of techniques, both supervised and unsupervised. And finally, I told you there is a technique called social network analytics. What you are trying to do here is you are trying to detect the characteristics of fraudulent behavior, not for an isolated data point or an isolated entity, but by looking at that entity as a network of linked entities. This is a very, very powerful technique, especially for detecting money laundering transactions, because when criminals engage in money laundering activities, they create complex structures whose sole purpose is to make the transaction appear as a bona fide or a genuine transaction. Okay. Once again, let me stress upon this fact. None of these methods is sufficient in itself. They all complement each other because they focus on different aspects of fraud. So any real world fraud detection and prevention system will combine these tools and use them in a combination. Okay. I mean, of course, there could be a hierarchy. As a first step, I think you will use an expert-based rule engine that you have developed, which then would be complemented by an unsupervised learning technique and further complemented by supervised learning and social network analytics. But of course, I mean, this is a order which can vary from company to company depending on what their philosophy for fraud detection is. Okay, let me give you an example of how we do this. So credit card companies are one bunch of entities who have been pioneers in the usage of big data and analytics to develop fraud detection engines. So what a credit card company typically will do, whenever you have a credit card transaction, it will be registered in the systems of the credit card company, and several characteristics of that transaction, those characteristics can actually run into 100 or 200. It's not like 10 or 15 characteristics. Those characteristics could run into hundreds, which provide different details about that transaction. They will log all these things. I'm just giving you an example. For a transaction, they might log things like transaction ID, transaction type, date, currency, amount, time, merchant ID, merchant category, ATM ID, card user ID. They will essentially log in a lot of information. And by logging this information over a period of time, they will create a data set which will allow them to apply what we call descriptive analytics or unsupervised learning technique. One of those techniques is what we call outlier detection technique. The purpose of outlier detection is that if I give you a data set, you can tell me which of the data points appear to be an outlier which can signal abnormal or anomalous behavior. Remember, this is not a confirmed fraud, it's just a red flag. Okay, and you can have that red flag raised either at the level of an individual transaction or at the level of an individual customer entity. So for example, if you look at this figure, look at this figure. It essentially talks about on the y-axis you have time and you have the place where the transaction is happening, and what it is trying to do, it is trying to apply what we call clustering algorithms to cluster these into different groups. And you can see it has found out two transactions which do not seem to fall in any cluster, and they could indicate abnormal or anomalous behavior. Okay, you can see these two transactions. So here, for this particular customer, you have the set of all the transactions they have done, and you are trying to figure out why these two transactions appear anomalous. Similarly, when you apply for a credit card, okay, now this is at the customer level, not at the transaction level, they find that there is some kind of a relationship between the income and the age of the people who are applying for credit cards. Just a hypothetical example, okay? And you can see there are two cases which are outliers who are applying for credit card. Okay, so this age and income combination does not seem to gel with the data for the other customers, and therefore it could indicate anomalous behavior and warrants more scrutiny. Okay, so this is how you use unsupervised learning. Now what they can do on top of that, because they have a data set, each transaction can be labeled as either a fraudulent or a non-fraudulent transaction. Once they do that, now predictive analytics or supervised learning comes into a picture, wherein they will create a predictive model which will predict an instance or a transaction or a customer as being fraudulent or not being fraudulent. Okay, the whole idea behind a predictive model is it is trying to understand or trying to figure out what is the relationship between different variables for a fraudulent transaction and for a non-fraudulent transaction. And based on that, next time you punch a transaction, it will try to predict whether a transaction is likely to be fraud or not. So for example, I've given you some such patterns which can be used by supervised learning. Say a small purchase followed by a big purchase could be fraudulent. Large number of online transactions in a short period of time, fraudulent. Okay, someone trying to spend a lot of money very quickly, or trying to spend small amounts spread across time so that they don't come on the radar. Okay, uh, these patterns may be hard to detect. These patterns are hard to detect. They are refinements which have been created by the fraudsters to deceive the fraud detection system, and therefore supervised learning technique may be very good at figuring out these alarms. Okay, next Okay, and now if you have to develop a machine learning or a statistics-based fraud detection or fraud analytics model, there are certain characteristics or objectives that you have to fulfill. The first objective would be what we call statistical accuracy, which we call the detection power. How accurate the model is in terms of detecting abnormal behavior. So you have a lot of specific statistical evaluation criteria. So for example, you have, if you do logistic regression, you have something called the ROC AUC curve. You have something called lift curves. All these are different techniques, statistical techniques to benchmark how accurate your model is. A very important objective, and especially these days, is your model should be interpretable. Interpretable means if your model has flagged something as a fraud, you should be able to explain it to someone why this has happened. So there are two types of models. Models which allow the user to understand why the model flagged a certain transaction as a fraud transaction. Such models are what we call white box models. And then you have complex models wherein you only get to see the output, but if someone asks you to explain how that output came in the first place, you will say, I don't know. Black box models. So for example, an example of white box model would be something called a decision tree. Whereas a black box model would be, say, an artificial neural network. This is a big requirement these days, especially in the financial services sector, where machine learning models are being used for, underwriting, for fraud detection, because the regulator ultimately wants to understand why the model is giving a certain outcome, and is the model driven by, say, some kind of a discrimination or some kind of a bias towards a particular group or category of customers. Okay. So that is one characteristic that you have to fulfill. Then you need the system to be operationally efficient. You don't have all the time in the world. You have to make your decision in a given amount of time, whether the transaction appears to be suspicious or not. Okay. This would also include what kind of efforts or cost or resources you will require to process the data, to backtest the model, what it will take to, say, recalibrate the model. This is very important, especially when you use neural network. A neural network sometimes can be very effective in fraud detection, but if you have to recalibrate the neural network model, it's a hell of a task. Okay. Then you are bothered about the cost, economic cost. What is the cost to gather data, pre-processing, data cleaning, data analysis? What is the cost to put the analytical model or the ML model into production? The software cost, the computing cost, all these things have to be analyzed. And finally, you need a model which has to be compliant with existing regulations. These regulations could be internal, specific to your organization, or it could be an external regulator by the Financial Services Authority, by the government, with regard to what kind of models you can develop and what kind of models you can apply. Okay, they could have regulatory compliance in terms of what do you do with the data that is being collected by your model? How does it address the problem of data privacy? How, for example, you are using cookies in a web browser? All those things are part of the compliance regime. So let me just give you an example in terms of accuracy versus explainability. The rule of thumb is more complex or black box a model becomes, accuracy will improve, but interpretability will go down. So you can see neural networks at one end of the spectrum, highly accurate, impossible to explain. On the other end of the spectrum, you have linear regression. Very simple model, may not be very accurate, but easily explainable. Now you have to figure out some kind of a compromise. So like random forest, for example, to me, and my understanding is that this is a very widely used technique in fraud detection in the real world also, because a decision tree, a random forest ultimately is a what you call a bunch of decision trees. These are what you call ensemble models. What an ensemble model does, instead of creating a single model, you create multiple models, and your outcome is determined by the collection of the outcomes of all these models. So random forest essentially is a collection of decision trees, each of which have been trained in a different fashion. And a very simple way is the outcome would be whatever is the decision of the majority of the tree, majority decision is the decision of the forest. So this is because it's a tree based approach, so it is explainable, it is interpretable, and I think it also has a relatively decent accuracy. Okay, so this is one aspect. Now let's talk about some of the challenges in using the ML techniques. So there are a lot of challenges. The first challenge is fraud is dynamic. Fraudster is always trying to beat the detection system by developing new methods. Therefore, your model needs to be adaptive. You have to have a model which is able to detect and resolve fraud as soon as possible. It needs to adapt. That is one thing. Also, there will always be a trade-off between good detection power versus false alarm rate. Okay, the reason is when you train your model on a data sample, on a training sample, remember, if there are 100 or thousands of data points in the sample, only 5 or 10 of those data points would be fraud cases. So when you train your model on a training sample where the actual occurrence of the event is rare, any prediction that you make based on this such a model could be a false alarm. And you want to resolve that trade-off, because see what happens is if you flag a transaction as suspicious, okay, what are the pros and cons? The thing is, it actually was a fraudulent transaction and you were able to save a lot of money. The con or the disadvantage is if you are having a lot of false alarms, then your customers would get irritated. You don't want to harass your customers. You don't want to, block transactions unnecessarily. Okay. And another aspect there is the data which you use for training the model, especially for things like fraud, credit defaults. The data is skewed. The data is skewed. When I say data is skewed, what I mean is in your data set, historical data set, you will have a lot of non-fraudulent cases, but only a limited number of fraudulent cases. In terms of classification algorithms, this is what you call an imbalance to classification. That means when you try to train the model on a training sample, suppose there are two categories in which you have to classify the transactions A and B. In the training sample, 99.5% belongs to B and only 0.5% belongs to A. Imbalance classification. There are a number of techniques to overcome this, and finally, you need, in a lot of cases, operational efficiency is the key, and therefore the fraud detection system might have a very limited amount of time available to reach a decision so that it can either let the transaction go through or block it. So for example, in a credit card fraud detection system, the decision time would be like in a few seconds. So if the detection engine has to be such real time, it will impact how you design the operational IT system, but it will also impact how you have to design the analytical model. The model should not be something that will take too long to be evaluated. Okay. Similarly, the information or the variables that the model is using for decision making they should not take too long to be gathered or calculated. So these are some of the challenges that you will come across when you try to use the ML techniques. And finally, I will want to talk about, okay, what are some of the skills that you will require as a fraud prevention data scientist, because this is a hot field. This is a field which is pretty much in demand. Uh, Most of the job applications or job requirements that I have seen on platforms like LinkedIn, they require some common skill sets. The first thing they require is that whoever the fraud detection data scientist is, they should have a good understanding of statistics and machine learning techniques. Okay, but that is only part of the requirement. What you need to know about is not only the entire suite of techniques, but also about which technique will work in which case. You need to have a good understanding of what analytical problem a particular technique will solve and how to interpret the results of that particular technique. This is very, very critical. Okay. Also, it is very important that you have to spend enough time validating the analytical results. Validating the analytical result. Why it is very important? Because you will find that if you torture the data enough, if you are hell bent on finding some pattern in the data, you will end up finding it. This is what we call trying to discover spurious correlations. Okay, so to avoid spurious correlations, you need to be aware about the limitations of each analytical technique, what context the technique can be used, and what is the business problem at hand. So that is one area where you have to be good. Secondly, because you have to work with data and analytics, you need to have some kind of a capability in programming. You have to do sensitivity analysis, you have to do model estimation, you have to do sampling and pre-processing of data, you have to do back testing, you have to do model deployment. You need to be comfortable with some software programming. It could be in SAS, it could be R, it could be Python. I'm not saying only one of the some technique is superior to the others, but you need to have at least one thing in place. Okay. Also, a third thing that they all require is your ability to visualize and communicate data. Because remember, developing the engine is an analytics based technique, but your consumers are business users who are not tech people. You need to be able to explain the results of your model in a non-technical sense to business users so that they can understand what it means for them. Okay. And finally, and this is again in specific contexts, what happens is, I told you there are different kinds of frauds: credit card related frauds, banking frauds, insurance frauds, healthcare frauds, counterfeiting, you have identity theft. Each of these fraud is a different context, and you need a model which can understand that context. So what you need is some kind of a domain knowledge, especially at a senior level. Okay, so these are some of the things that I wanted to share about the fraud detection systems and how ML techniques are being used and different aspects of ML. So that's all from me. Thank you, Nitish. Open for questions.
Wonderful, very, very informative, Ritesh. So I hope that the participants also got a very, very detailed information about like the system. Of course, these are heavy topics. We can go on, but in a short span of time, you actually have summarized things very, very succinctly and very well, right? So before we go into the Q&A session, maybe just to give Ritesh a breather also, and also to maybe showcase what we have been trying to do our bit in promoting the awareness education in this field for like, I mean, now more than 1.5 decades, right? So very briefly, and for those who are interested in like learning more details in detail about all this, making a career in this field, just like to give some heads up on how you can go about it. So firstly, as you all know, we are Indian Institute of Quantitative Finance, and we have been a pioneering body in quant and financial engineering education in India. So we have been tirelessly promoting this field in India for like more than 1.5 decades, and we were founded by pioneers in India and top experts from the fields of financial risk management, financial engineering, investment banking, with educational background from top institutes and having experience in the top places, right? So I mean, for those who are interested in like learning deep about all these areas, there are different, very strong, comprehensive courses that we do, which prepares people for careers in this field. And they are, I mean, if somebody can do any of these courses seriously, they actually would be job ready and join the relevant teams in different financial areas, right? So there are different courses. So if somebody is interested in like understanding about the field of data science and machine learning, particularly as applied to finance, then the course that we do is like a 9.5 months course called Certificate Program in Artificial Intelligence for Finance. So basically a course which covers all aspects of data science, machine learning applications in finance, and then depending on your area of interest, you can actually choose to super specialize in one of the application areas, risk management or derivatives, valuation, or applications in trading or generative AI in finance. And so basically you can select to specialize as well, right? And all this AI for finance being like a 9.5 months long duration course, if somebody is not interested in doing the entire course, they can selectively do part of the course as well. So if somebody wants to concentrate only for the learning the machine learning applications in finance, they can do that part of the course. It's a separate 4-month module which you can individually do as a 4-month certificate. If somebody is interested in only understanding about the data science part of finance, data science part and its application in finance, they can do the 3 months module on data science for finance, which would again teach all aspects of data science, data engineering, big data, data visualization, Power BI, Tableau, and all that, right? So they can do that part. Or, I mean, if you want to specialize in the other areas, and again, if you want to go deep into understanding about and become a quant in the industry, so there are courses which specifically prepares you for the quant and risk management team. So if somebody is inclined with heavy mathematics and mathematical modeling, they can look at this course called Certificate Program in Financial Engineering, which prepares you for the quant roles in the international banks, big four consulting firms, trading desk, and all that places. If somebody wants to concentrate a little bit more on the risk management side, maybe not so heavy on the quant side, then there's another very deep and comprehensive course we do. It's a course called Certificate Program in Quantitative Finance and Risk Management, which is about 6 months. For people who are interested in like algorithmic trading, understanding about the entire scheme of things on how to go about building an algo trading system using different kinds of strategies, maybe technical analysis based strategies, machine learning based strategies, quant model based strategies. They can look at this course called Postgraduate Program in Algorithmic Trading. And then these are specialization modules which we have. I mean, if somebody is very good with basics of data science and machine learning, they can directly go and do these modules, and they can, basically specialize in different application areas of machine learning and data science in finance. They can choose to do courses in generative AI for finance, or AI for trading, AI for risk management, or AI for derivative valuations. The good thing about all these courses are these are very deep, comprehensive, that's fine. But again, you can do this along with your job, or if you're pursuing any other degree, you can do along with your other degree programs as well, right? So these are all conducted through online, live, and interactive sessions on the weekends, Saturdays and Sundays. So you can do it along with your job, or I mean, if you're pursuing any other degree, you can do it along with that, right? So I mean, in the last 15 years, of course, we have been fortunate to have a lot of students from the industry and academia who have pursued these courses, and they have pretty much made their careers in this kind of fields in quant, risk management, trading, now machine learning and related areas in finance. some of them has been very kind enough to share their thoughts and on how they have utilized these courses to build their background and make like a mark in this field. I mean, these are just like a very small sample of people. These are, I mean, we have thousands of people who have trained. So just like, this is not to showcase or like advertise the courses. This is just to show, I mean, for you to encourage you to understand how people have benefited from the courses. And if somebody is interested, somebody wants to enter into this field, or somebody already working in this field, wanting to go more deeper, right? So they can always utilize these courses and build their background and go deeper, right? So, I mean, if somebody is doing our courses, of course, basically a very important reason why people do this course, apart from the knowledge that they gain, is to actually get a job in this field. Of course, a lot of people are already working. A lot of our students don't need a job, but a lot of them do need a job. I mean, even if they're working, they want to change into this field. So there is a strong placement support system as well. And it starts absolutely from the beginning. When you touch base with us, even before joining the course, we counsel you, we understand your background, and we suggest the right approach on what kind of courses to be done, what kind of background preparation needs to be done, and then accordingly actually help you in selecting the right path, right course, right? And of course, once you join the course, all the courses are taught by leaders from the industry like Ritesh, and there are many other mentors from the industry who would be teaching the various courses, particularly from quant, risk management, or different parts of the industry, right? And once you have done the course, understood the course, then the placement support team takes over. They would work with you on the entire process: resume building, interview preparation, your LinkedIn profiling, and then they will start helping out with your interviews and interview preparations and all that. Yes, of course, a very strong network of industry association. We ourselves are from the industry, so I mean, in any case, we do have, most of us have like a very long association with the quant industry for like maybe 2 decades or more. And then the faculties are like from the top place in the industry. The students in the last 15 years, a lot of them have gone on to leadership positions. There's a dedicated team which continuously interacts with the different recruitment teams of international banks, Indian banks, financial institutions, trading desks, big four consulting firms, wherever this kind of job is there, right? So they regularly touch base, interact, and get you the interview calls. And as I said, resume building, interview preparation, so the entire process of like the entire steps and process in the placement system, right? So yes, I mean, just to mention that how you can utilize and to enter into this field. So you can always join any of these courses, build your background, and then again use our services to also connect with the industry, get a right job, right? I mean, not going very deep, you all know what kind of companies to be targeted, right? So the hedge funds, Menace Technology, DISA, Citadel, the international banks, Goldman Sachs, JP Morgan, Citibank, Nomura, stock exchanges, NYSE, NSC, the consulting firms. A lot of people don't know. I mean, these consulting firms, they have their quant and risk advisory team, so they hire also a lot. I mean, last 5 years we have seen that their hirings are almost equal to like the international banks, particularly in Indian teams, right? Yes, of course, the IT companies, they do have a lot of supports, provide a lot of support to like the financial institutions. They also hire heavily in the quant and risk analytics teams, right? So yeah, I mean, this is like broadly some set of kind of teams or profiles that you would be targeting by doing this kind of courses. Again, not going very deep. So essentially, like these are things, I mean, or the roles that one can target by doing this kind of courses. Yes, and it has been a long journey. There's a very small indicative list of the kind of people we have been working with in various capacities, be as their trainers, be as their consultants, or like again, a lot of them help. I mean, are in recruitment as well, taking our students for different kinds of roles. So there are different kinds of associations. Practically everybody working in the quant and risk management team, we work closely with. And yes, as a part of our endeavor, I mean, we work with a lot of institutes as well, like promoting the quant field and the related areas amongst the student community. So we have been doing our beat. Of course, when we started out, this was pretty much a very unknown commodity, the quant. areas, right? Even with the industry people, but now things are a lot better. Even student communities, a lot of them know about this field, but still we do our beat in promoting this field. This is again a very small indicative list. So we work with many top institutes to actually conduct a lot of events, workshops, seminars actually to promote this field. Yes, and of course, anybody wanting to contact us to discuss anything, I mean, not necessarily to do a course. If you have any questions, queries regarding your, I mean, how to shape your career, or like again, any particular questions that you have is nagging you, please feel free to reach out. We'll be happy to help. Of course, if you want to do our course, also we'll be definitely be very happy to guide you. But otherwise, also please feel free to connect and discuss, like again. All your questions, queries related to the field, right? Okay. So now coming back to, so let's like again, there's a lot of questions that people have. So Ritesh, I'll be collating the questions for you one by one, and please maybe answer those questions. Okay, so the first question is from Satabdi. So Satabdi works with SBI Securities and has 4 years of experience in AI and machine learning. So her question is, do we need deep learning for fraud analytics?
Yes, I mean, these days, most of the real world models that you see in large organizations, they have started gravitating towards neural networks, because I told you neural networks might be providing the most accurate answer in the entire gamut of models that are possible. So models like logistic regression, linear regression, they are okay. But in the real world systems, deep learning is something that you need to be aware about. You need to know about neural networks, because most of the advanced algorithms, most of the advanced techniques, they ultimately would be using neural networks or deep learning.
Right, absolutely. I hope that answers your question, Satabdi. Any follow-up question, please feel free to type in. We'll be taking it up. Then let's proceed to the next question. The next question is from Mrinal. And he has specifically asked, where can I learn machine learning specifically tailored for fraud detection and forensic accounting? So let me start answering this question, and if you have to add anything, Ritesh, please feel free to add. So first thing is, Mrinal, there are thousands of machine learning and data science courses available worldwide, right? So I'm not saying any specific. First thing is to understand the domain of machine learning and data science, right? So essentially, like again, that you have to understand that in deep, and then I mean, of course, apply that to whatever area you want to apply. But yes, if you want to specifically learn, I mean, I'm not saying only specific to fraud detection or forensic accounting. Of course, that is also that is something taken up. But again, if you want to learn machine learning and data science in context of finance, then actually, I mean, our courses are specifically tailored to that, right? I mean, when the most people who institutes, when they teach data science and machine learning, of course, they have to take sample data from some or the other industry. But generally, these courses are not specific to any particular industry. So people take examples of different kinds of industry, maybe marketing data, maybe HR data, maybe medical data, maybe some amount of finance data. So they generally teach it using mixed kind of data from different industry. But we, being the oldest quant body in India, everything we do is in context of advanced finance and financial analytics. So whatever we teach is in context of finance. The data, all the data that we take, all the case studies, the research papers, white papers, everything that we take up in our courses are in context of finance. So I mean, this fraud detection and forensic accounting, these are also like part of like the courses that we teach in data science and machine learning. So if some you are interested in the understanding about machine learning, data science application to fraud detection, forensic accounting, and other areas of finance, you may consider our course. This is as well. Of course, I mean, as I said, this is not necessarily you have to do it from our course. You can actually learn data science, machine learning from different other places as well. But if you want to learn specifically for finance, maybe our courses are a good source to learn, right? All right. So next question is, okay, sorry, Ritesh, you want to add anything?
Yeah, I mean, the only thing I can add there is that look, when it comes to the machine learning technique itself, that is pretty much domain agnostic. So even if we talk about fraud detection, see, I talked about unsupervised learning. In unsupervised learning, there are sort of generic techniques. You learn about
Correct.
graphical techniques like multidimensional data analysis, how to roll up data, how to slice and dice data. You learn about clustering techniques. You learn about statistical outlier prediction procedures like breakpoint analysis, association rules, self-organizing maps. Similarly, in supervised learning, you will get to learn about, say, logistic regression, decision trees, ensemble models, bagging, boosting. So you can pick up, I mean, you can Google or you can pick up any material and learn about that. As far as the domain knowledge is concerned, see, either you are working in that particular domain, then though you will be aware about that. Otherwise, of course, it will only come with time. So domain knowledge is not something, I mean, what is so special or what are the key characteristics of data, say, which pertains to insurance or which pertains to e-commerce, or what is the nature of frauds which take place in the e-commerce? Probably, I think you can get this domain knowledge by reading articles, searching on Google specifically about these topics. People write blogs, you have material available. You wouldn't become an expert unless and until you work in that, but at least I think you would have a level of awareness that you can converse to something about that. So a lot of times even that might help a lot.
Absolutely. But a small addition actually, it is, yeah, of course, the general techniques are same. But again, if you learn it specifically to a industry, then there are certain small adjustment to the techniques that you actually sometimes needs to do. So as I mean, as I also mentioned, you can learn from anywhere, general data science and machine learning. But if you have a specific interest in a particular industry, then I mean, it might be helpful to learn from courses which specifically teaches that in that context, then actually you are even more aware of the techniques in that field. So just as an addition. Right. So the next question is from Mohammad Ali, and he has mentioned, does the random forest model also take care of bias? Will we be able to determine the accuracy then?
Does the random model take care of which bias? Sorry, I did not understand the question.
So he has only mentioned, does random forest model also take care of bias? Will we be able to determine the accuracy then?
No, the accuracy, so you will be able to determine for anything, for any
Right.
model. The point I was trying to make was that essentially there are a class of techniques called ensemble techniques, and random forest is one of the ensemble techniques, wherein you say that, look, instead of relying upon a single model for the prediction, I would use a cluster of models or a family of models, and then use some kind of a combination of their outcomes to arrive at the final outcome. That's what a random forest is, nothing more. Okay, and of course you can evaluate the accuracy, the errors of that technique, just like any other technique. So there is nothing very, I would say, different about random forest as such. They belong to a general class of techniques. About the bias part, actually, I was not very clear of what you meant by that. So if you can explain that later, probably offline, then I will try to come back to you on that.
Yeah, sure. I mean, and you may type in your a follow-up question as well. If we have time, we will definitely try to take it up. Right. Thanks for that, Ritesh. So let's go to the next question. This is from Vinod, and Vinod says that first of all, thanks for taking out of Sunday. Thanks, Vinod, for I mean for joining the webinar also on Sunday, right? So thanks for joining. So what is the current regulatory guideline on using machine learning models for losses, RWA calculations under IRB in terms of interpretability versus accuracy? Since IRB floors are going up and limits uses in most portfolios, cost saving ratios would be higher in adapting this machine learning models under Basel 3 1. Are most use cases currently operational for internal risk management and customer cross-selling purposes? It's a long question. First of all, would you like to take that question, or would you like to repeat the question? I mean, me to repeat the question.
Can you repeat the question once again?
Yeah, sure. So let me read it again a little slowly. So he has asked, what is the current regulatory guideline on using machine learning models for losses /RWA calculations under IRB in terms of interpretability versus accuracy. The second part of the question is, since IRB floors are going up and limits usage in most portfolios, cost savings ratio would be higher in adopting this machine learning models under Basel 3.1. Are most use cases currently operational for internal risk management and customary cross-selling purposes?
I think this is, I'm sorry for this, but I think this is very specific to people who work probably on the credit modeling or capital modeling side of that.
Correct.
So this is very specific to that. I don't have that detailed information, but I do know that especially in the European Union, the European Banking Authority, they have been coming up with some guidelines in terms of how the ML techniques can be used in the banking sector, and specifically with about what you have mentioned, the internal rating based or the IRB models. So they have come up with some discussion papers on that. They also have a requirement in European Union that these internal credit risk models have to comply with some of the other legal frameworks like the General Data Protection Regulation, GDPR, and EU also has an Artificial Intelligence Act, AI Act, with which they have to comply. But the exact details of these factors, I will have to check and get back to you. I am not aware about that at this point of time. Sorry.
No worries, Ritesh, that's absolutely fine. And we know there are within our faculty team, there are members who are working in different areas of ML applications in finance. So please feel free to connect later with us, and we would be happy to maybe connect you to a resource person who would be specifically working in that field, and again they would answer that in detail. In the meantime, Ritesh can also again do a little bit of research, and he can also get back. So please feel free to connect separately. We would be happy to connect you to someone who can answer that question in more detail. Right? Hope that is fine, Vinod. All right. So going to the next question is there from Ashish. First thing is there any course specifically for fraud, deception, or detection? I am not really aware of like any specific course on that, but yeah, that's part of some of the courses that we do. So these are covered particularly from the risk management or machine learning perspective, but specifically a small module only on fraud, deception, or detection, as of now I am not really aware of. Right, but yeah, if you want, maybe we can take a look. If there's anything specific is there in terms of those kind of courses.
Yeah, even I'm nothing comes to my mind offhand that there's any specific course as such.
Right.
But we can check. We can always check. I'm not aware about any course which is specifically targeting fraud detection using AI or ML. You might find some courses on Udemy. People might have posted some courses on Udemy, but if someone actually has a classroom-based course around that, we'll have to probably check. I am not aware.
Right. So he has a follow-up question. So I'm not sure whether the question is very clear or not. Then maybe I would ask him to elaborate. So what Ashish has asked is for contextual data, how we can deal with what, Ashish? I'm not really clear. Are you clear with the question, Ritesh?
I think probably he's trying to ask, I'm not sure, but probably what he's trying to ask, if we need business domain specific data, say insurance data or some e-commerce fraud related data, where can I get that? Again, Ashish, that's a challenge because you wouldn't be able to get it. Most of this data is proprietary data. Probably one place where you can search, there are these Kaggle competitions which happen, for which they give you different problem sets. I'm sure they would have done some Kaggle competitions around fraud detection as well. There you might find data which would resemble real world data, and you can use that to learn from.
Correct. I hope that answers your question, Ashish. If not, then please feel free to maybe add up to the question, or maybe like give a little bit more detail on what you're asking. But if that does answer your
Similarly,
question.
I think I have come across some courses on Coursera also, which
Right.
deal with how to use AI for fraud detection. So you can, so there you can go and you can go through those courses.
Right. Fair enough. All right. So there's a follow-up question from Satabdi actually, or says actually it's a statement more of. So some of the clients are getting detected in anomaly detection are good clients, but showing patterns as a fraudulent clients. What to do in such cases? Yeah, sorry, it's a question actually. It's not a statement.
So, I mean, that will always happen, Shatabdi. I mean, that's the nature of the game. So you will always have. So essentially, what happens is, if I can just write this on the.
Okay, no, let me make you the presenter. Just allow me a second. Yeah, you have another.
So just.
You have to show your screen.
Just a sec. Can you see my screen now?
Yes, yes.
Okay. See, what happens is whenever you are doing, ultimately, fraud detection is a classification problem, wherein you have to predict or classify a particular transaction as a fraudulent or non-fraudulent. When you do this, essentially it's a binary classification problem. Either it goes in the fraudulent class or non-fraudulent class. You will always have 4 outcomes. So you will be having true positives, you have false positives, you have true negative, and you have the false negative. Okay. And the objective of the analytics or the machine learning model is that you want to maximize these two. At the same time, you want to minimize these two. Remember, they can never completely be made to go away. So that is where you fine tune the model. That is where you use the benchmarking. There are different statistical techniques in use, but this is a real world problem. It will always remain. There are bounds. So the trade-off is you could have a model which is very good at flagging red signals or an alarm, but a lot of those flags could be false positives. So you want to avoid that. You can never bring it down to zero. Some of it will always remain, but yes, you can always improve the performance of that model in terms of these parameters. So it will remain, but there are techniques to improve upon that. And probably you can easily find about those techniques if you Google how to improve the precision or the recall or the accuracy of the classification algorithm.
Right, absolutely. I hope that answers your question. Okay, so now to quickly wrap up, we'll be taking up the last 2 questions actually, and I think that anyway that would actually be covering all the other questions, because some of the other questions are repetitive. So maybe we have already covered in answering the other questions as well. But the last 2 questions actually. First one is from Zalak, and Zalak has mentioned, I have data science internship experience in NBFC, currently looking for full-time opportunity. What, or rather, which skills from fresher data scientist in finance industry? So first thing is, before Ritesh answers the question, Zalak, I'm assuming that actually you already have data science and machine learning knowledge. In that context, shall we answer, or like again, correct me if you are wrong, if we are wrong actually. So I mean, we are assuming that you have a background in data science and machine learning. Is that a fair assumption? Zalak, if you can like quickly type in. Cool. Okay. Yeah. So Zalak has a already understanding about data science and machine learning, and she says that she has done a data science internship from an NBFC. So currently she is looking for full-time opportunity. The question is, which skill sets or which skills expected from fresher data science scientist in finance industry? Ritesh, if you can actually guide her a little bit.
Yeah, so I think the first thing is that you have been a part of that industry. I think that itself is a good first step, that you have the contextual understanding. Now, in terms of skill set, I mentioned earlier that they will essentially grill you, or they will expect you to have knowledge of the statistical techniques, even though you may not know about the deep learning stuff, but at least the traditional statistical stuff, regression, decision tree, ensemble models, clustering algorithms, those are a bare minimum. and programming language. I think if you have these two, then for an entry-level position, that should be good enough.
Correct. Correct. So I hope that answers your question, Zalak. Okay, there are follow-up questions from Ashish, and with that will be the last question that we'll be taking up for today. So Ashish, first of all, is working as PhD researcher, working in fraud detection only already, and his question is that, like, again, with how to deal with model accuracy in social media data. So I mean, he says that I'm working in regional language fraud detection and I'm struggling to collect the data set.
Regional language?
Regional language fraud detection. I'm struggling to collect the data set. So how do you deal with model accuracy in social media data?
What do you mean by regional? What do you mean by regional language fraud detection? Sorry, I could not understand that part.
Like in Hindi, he mentions.
Now, where will you get data for that? I mean, which bank or financial institution would maintain that data in Hindi?
That's definitely a real challenge.
We'll have to check. I'm not aware of any sources such, any databases which keep.
No, he's actually saying social media data, right? So what he's saying is it was a follow-up question, if you remember. So essentially, we discussed about his. The first question was for contextual data, how can we deal with? So that was an incomplete question. So he has added to that question. So how to deal with model accuracy in social media data, particularly in regional languages?
Model, but what is the purpose of your model? I mean,
he has created some manual. Person is comment in Hindi in social media. So it's like trying to create like some manual for that.
No, I understand, but when you say accuracy, so for example, we have been talking about fraud detection. Their accuracy is meaning is straightforward, that it should be able to recognize a fraudulent transaction or the traits of a fraudulent transaction. When you say that it's social media in general, accuracy, what are you trying to predict? I could not really understand that part. What are you trying to predict? So probably what we can do is, if he can give us some more context and connect with us, I would definitely love to answer this question. But probably I need some more context of what exactly he's trying to achieve.
Right. So basically, like, what I understand is, like, again, like, people are trying to study overall social media data to understand fraud. So he's specifically concentrating on the people who are
social media to understand fraud. Is that the thing?
That takes data in social media. So basically, I mean, here actually people are is trying to understand the people who are inputting their comments and everything in Hindi particularly. So basically, 100 Hindi comments in social media takes data and all that. So essentially, he's trying to analyze that.
So exactly in Hindi, I am not aware, to be very honest, but I do understand. So I have done, I mean, I'm slightly conversant with how you use the social network analytics as such. And I think that will be relevant for you, how you use the data available on, say, social network sites. So what people do, they mine that data to figure out relationships between people. Okay, the whole underlying concept is that fraud ultimately is a social phenomenon. It is not limited to one person in isolation. It is a social phenomenon, which is like saying that birds of a feather flock together. So it says that people have a strong tendency to associate with others whom they perceive as being similar to themselves. Okay, and some of the techniques which I have seen being used as part of social network analytics is, so they use metrics like neighborhood metrics, they use centrality metrics, they use collective inference algorithms, they use a lot of what we call the graph theory to find interconnection or relationship between entities or between individuals. So I've seen people doing both unipartite graphs, bipartite graphs, then you have the multipartite graphs. All these techniques are used to mine the data available on social media websites. The whole idea is the objective is to figure out who are the persons which are connected to you, and does this paint some kind of a picture in terms of whether you are engaged in fraudulent activity or whether some fraudulent activity is happening in your circle or not. Okay, so if you can get some more context on this, I would be very happy to explain this further.
Yeah, he has added few lines actually. So essentially what he's trying to do is I've explored a lot, but very less work in this area. And in next generation, regional language is coming actually. And challenge is English sometimes also is a problem. And he mentioned that they are also developing complete graph, but still not working. So the thing is like, I mean, generally, I think, I mean, see, he's already doing like a PhD in a machine learning related area. So the general context, I think he understands. But again, he is actually trying to brainstorm about like the specific problem that he is facing, because he's trying to use original language data, which is not done by a lot of people, right? So yes, I understand it. I assume that he says that he is himself a data science trainer. So yeah, that is something I was already understanding, that you already have a strong understanding about the general domain, right? So he was trying to discuss the specific problem that he is facing. I mean, in general, that's like a very I think a problem which is not explored much. So I mean, he's trying to actually brainstorm. I mean, that is what he's trying to do. I believe, right? So it's not like, again, he's actually like, again, doing a lot of research on that, but it's not found out. I mean, but yeah, Ashish, so unfortunately, again, not a lot of work has been done in this. So essentially, maybe you would be one of the people who would be who will be in the forefront in like, again, working in with regional data and the related areas, right? So, but yeah, I mean, this is something we would be very interested in, like, again, keep on interacting with you and like maybe discussing how things are progressing. And maybe like from our side also, if we can add something, that will always be great actually, right? Yeah, we can understand you have worked a lot on the last few months, right? I understand, right? So anyway, that is something. It's like a thing which we would actually it's a research which actually we all need to work together on that. It's actually a new area that you are researching. Wonderful work that actually you are doing. So yeah, I mean, we will interact more on that. Please keep us posted on your more findings in detail, and we would also be happy to maybe discuss and contribute wherever we can. Right. So with that note, I believe there are no more questions which are there for the day. I mean, as I said, some of the questions that we have, these are things we have already covered in some of the other questions that we have already discussed. So with that note, I would like to conclude the session for today. First of all, thanks once again to everyone for taking your time out and joining us on Sunday. And it was a very heartening to see your wonderful participation. It's such a large audience, which shows the interest this kind of topics has, and like, again, the repercussions that everybody is having on their respective industry. And so it's wonderful to see that. To Ritesh specifically, thanks once again for joining in, and thanks for your valuable time. It was a wonderful session. I mean, we got a lot of insights. So thanks so much, Ritesh. I believe.
Thank you so much.
Thanks so much. So with that, we conclude the session for the day. And as you all know, we do conduct this series of webinars on like very important topics in our fields of financial engineering, quant finance, risk management, algorithmic trading, AI, machine learning, and data science applications in finance. So keep track of our various social media pages, our websites, and of course, those who have registered, you will also receive intimations over email and other modes about all the next upcoming webinars. So keep track, and I hope to see you in the next webinars as well. Thank you once again for joining. Thank you. Goodbye. Yes, Ashish, we would be putting up the recording later on.